leave the parking lot is modeled by differential function L. Selected values of L of t are given in the table above. Both E of t and L of t are measured in cars per hour, and time t is measured in hours after 5 a.m., where t equals 0. Both functions are defined for 0 is less than t, which is less than or equal to 12.
And then part B?
How many cars enter the parking lot from time equals 0 to time equals 12?
Okay, so at t equals 0 is 5 o'clock. So that means when t equals 2, 2 hours after 5 o'clock is what time? 7 o'clock. And then 12 hours after 5 o'clock will be, is it 5 p.m. or a.m.? Oh, it'll be a.m. Okay. So then, how many cars are entering? So we have the formula of the entering. And because this is a calculator portion, all you have to do is math 9. So let's write out the following. The way we're going to type this in is going to be from 0 to 12 of E of t dt. Let's practice typing that in. These are more of a freebie. Go to math 9, and we're going from 0 to 12. And type in the function exactly as you see on the top. Except in place of t, you'll put in the x. 1 side. And then second, natural log will give us the e to the power 0.2 x. The only error will be if you just type in the wrong thing, which could happen. And that's going to give us 520. So it says give your answer to the nearest whole number. So then we have to write the sentence on this one. 520 cars enter. And we're literally copying this right here. All that. Rewriting the statement is always good. So 520 cars enter the parking lot from, the lot, from time t equals 0 to time t equals 12. That's a 12. And the way the AP graders are going to grade this, it's going to be having this one right here. It's going to give you 1 point. Rewriting the answer with the statement given will be another point. Always restating the problem is a good idea. Always, 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 always. All right, let's go on to part C. Okay, Jillian, let's read part C.
Use a trapezoidal sum with the 4 set intervals indicated by the data in the table to approximate L to LT dx using direct intermediate 12 to LT dt in the context of this problem.
Okay, so then for this one, we're looking at trapezoidal. Did it say how many subintervals? 4. So that means I'm going to go 1, 2, 3, 4. Just to recall the trapezoidal sum, or the formula. It is base 1 plus base 2 divided by 2 times the difference between the time. Okay? So then, if we were to put that in, it's going to look like the integral from 2 to 12 of LT dt is equal to. So then I'm going to put a bunch of parentheses. We have 15 plus 40 divided by 2. What's the difference of the times between, for the first one? 3. Plus, the next one is 24 and 40. I think I'm going to write 40 first. 40 plus 24 divided by 2. Difference between 5 and 9 is 4. And then I have 24 plus 68 divided by 2. The difference between 9 and 11 is what? 2. And then I'm going to try to squeeze it in. We have 68 plus 18 divided by 2. And the difference between 11 and 12 is times 1. Okay, let's all type that in. And again, if any error, it's you typing it in the calculator, which sometimes could be sad. I see people without calculators. Where's the effort?
What's at the very front of the equation? Is that
Very, LT of DT. Your answer should be somewhere in the 300s. Three how many?
45?
Yep, 345 point what? 5. And then so, let's see what this is representing. If we were to look at the beginning, it says the function L is the amount of cars leaving the parking lot. So we want to go ahead and say integral from 2 to 12 of LT dt is the number of cars doing what? Leaving. Cars that leave. Leave the parking lot in the 10 hours, because from 2 to 12, that's 10 hours. And specifically, 7 a.m., which was at t equals 2, and 5 p.m., which is t is equal to 12. And it's 5 p.m. because if t equals 0 was at 5 a.m., 12 hours after that must be p.m., right? So then we have having all of this, and they want to see the trapezoidal too. That's one point. And restating and explaining will be another point.